like Tom to come up as well, and please join the table, and let me introduce our panelists. First, Eric Giesa, who is the supplier partner for Tom. He is from Tempered Networks, based in Seattle. Second, Dan Miller from AT&T. Dan has worked in various parts of AT&T, so Dan has experience with utilities and with building automation, and of course brings the perspective of being from a major carrier. Last but not least, Roger Hill from Veracity. That is the technology partner for a number of companies providing SDN technology into primarily critical infrastructure. And utilities are probably the most critical infrastructure, electric utilities. So I'm going to ask just a couple of questions, if you don't mind, of the technology folks or the partners here, and then I'll very quickly open it up to the floor if you have some questions. Maybe starting with Eric, if that's okay. You have some comments on the manufacturing uses of the HIP or secure identity network technology. What do you see in the manufacturing space that are key variables or the key attributes that your customers are finding important? Because I think a lot of things that Tom talked about resonated in terms of the manufacturing space, but if you look at your customers in manufacturing, what are kind of the key drivers that they value in terms of having the network technology of the secure identity network? Right. Or you have to share a microphone. So
okay. Yeah. So I'll give you an example. We have a large multinational cast manufacturer. Has to comply with NIST, the cybersecurity framework, and the manufacturing profile. And a big emphasis of NIST is obviously segmentation, microsegmentation. But not unlike Tom, they too have significant time pressures and constraints. That's common across all industry sectors, and in addition to that, finding IT personnel to manage this environment is no small task, finding talent. So having overly complex solutions and cascading dependencies within network and security technology makes creating a very robust and secure network very, very, very difficult to do. This one customer, same thing, flat L2 network, needing segmentation, but job one is availability. This is a highly, mission criticality in a manufacturing or even in building automation system environment is very different than in IT. And I know IT, I've been in it for 25 years. Before I came over to Tempered Networks, I ran product at F5 Networks for 12 years. And it's a lot different when you talk about availability for Exchange server versus a CNC machine or elevator or lighting controls for a building or temperature controls or whatever it is. So availability is key. But in that scenario, when you've got these time pressures, the plant can't go down, I need to do something that's non-disruptive. I need to comply with NIST and the segmentation requirements, but I need that data to make really good, informed business decisions, as the gentleman from WAPA was talking about, power generation. All of these things are commonalities, and so it comes down to the underlying design and saying, how do we design something that is incredibly resilient, that's easy to microsegment, that's very flexible, where we can instantly add network things, revoke, replace, or disable. And it's, instant. You need that type of response to be able to recover. Becomes these key considerations in any type of design. And I'll finish with, our underlying technology is based on the host identity protocol. It's an open standard. And my interest, more than promoting tempered, is promoting HIP. And everybody in this room has the power to go to your vendors, and every single one of them, eventually, HIP should be native to their OS stack, period. End of story. It's the only way we're going to put the hurt on the bad guys. It is the protocol of the future, and again, it's not to benefit tempered, it's to benefit all of you, because if we have native host identity in every connected thing, we start to really get control of the Wild West, which is the internet.
Okay, thanks. Roger, what I've heard from people who are operating SDNs is, as the key thing they love is they call it lockdown. You know, it's a different environment that they have where they understand all the traffic, and if there's abnormal traffic, that becomes a report. You, Subhash mentioned that. I wonder are there other things and that your customers or users of SDN in an infrastructure or manufacturing sense see as a value? And another question there, if you don't mind, a two-parter is, what about the transition into an SDN solution from you might call, we want to call it legacy, but a wide open solution?
Sure. So first of all, I would say that the primary problem statement we set out to solve was the visibility. So visibility of what are the devices connected on to the switches, and then what are the machine-to-machine conversations. If you refer back to like a Purdue model, the closer you get down to the actual physical industrial process that's being automated, you have less and less visibility, because in those local PLC cabinets, you are running unmanaged switches that don't have span port capability. Not that span port should be used for security. So addressing visibility, you know, the one thing that we kept looking at is how do we solve the security problem without adding new software or hardware? And the one thing that we kept coming back to is all of the packets that were so critical and we needed to have more visibility for were already flowing through these switches. So let's solve this in a unique way. Let's repurpose the use case of the Ethernet switch so that it's not just forwarding packets, but forwarding packets if it should forward packets. And that was what led us to software-defined networking. So I think the primary value that most users see immediately is an absolute historical record of any device that's ever touched the network, every protocol ever communicated, and any communication between devices. It's technically impossible to connect into this network and not be known by the controller, because the switch no longer has the capability of making the decision how to forward. So that visibility is a big thing, but I think there's a lot of different SDN approaches out there. It really started with the campus LANs, and then it moved into some focus on the carrier networks, and then data center. Industrial is a different use case. I think when you look at the industrial, we had to first look at what's the right SDN controller. So we ended up writing our own because there was no real true fit. In doing that, we wanted to solve the problem in another ways. Let's get rid of the complexity. Is it really necessary? So let's think in terms of the operations users, in terms of a controls engineer, process engineer, or power engineer. These are the experts of what should be happening for that physical process that's being automated, right? These are the ones that know that that HMI should communicate to that PLC, but they might not be an Ethernet expert. So the advantage here is, or even the opportunity, is abstraction of the complexities. Let the user tell you what should happen from a security policy perspective, and then allow the system to actually generate all of the necessary flow rules to program the switches, and then present this to the user in a visual manner. Let's reduce the complexity.
Okay, that sounds great. Dan, You guys operate a network, don't you? Kind of a large one, and I would say it's critical infrastructure from my standpoint, because I use it. So, and I'm sure everyone else, and probably Subhash as boss, as an ultimate boss, you know, the government probably considers it critical as well. So, I don't know if you have a perspective or can give us some perspective on what you see from these kind of new network technologies for security from the standpoint both of, you know, your own business and your business customers, especially, really mean your manufacturing customers.
Right.
So, you know, can you give us a perspective on that at all?
I can try. So first I want to talk about the last session where Sid threw a slide up there that talks about cybersecurity providers. We weren't on there. So interestingly enough, AT&T is the largest shareholder in cybersecurity north of the factory, right? So it's a huge opportunity. And why is that? Well, we have 1.1 million miles of fiber. We have 3,700 MPLS nodes around the world that's moving data traffic, 220 petabytes per day. We actually analyze about 6 billion records through we have AT&T's big in big data, and that feeds into our cybersecurity. So inherently, cyber is part of our DNA. It has to be as we light up all of our customers' networks. You have to think about the threats that are coming from sponsored state terrorism and sponsored cyber attacks. Customers don't see that. Do you know why? It's because we actually monitor traffic in real time, and when something happens in our network that isn't normal, we flag it, we sandbox it, and we isolate it. So our customers that utilize AT&T's either MPLS network or evolving SD-WAN architecture are protected from a lot of the threats that are vectoring in from hostile environments to either steal your data, to try to destroy your equipment, to try to disrupt your business. And we have about 2,000 security professionals on staff at AT&T and eight global SOCs that's their 24/7 job. So cyber's big for us. All the three-letter acronyms in the U.S. use AT&T for cybersecurity, and there's a reason for that. Our perspective is north of the plant. It's not to say that we're not working with companies inside the plant on cybersecurity for OT, because they recognize our perspective, they recognize we bring a different set of expertise and visibility to the equation. And so over the last few years, we've actually started working with some of the big integrated oil and gas manufacturers to look at OT and how do we play in that space, right? Not to say that we're not a PLC company, we don't speak BACnet, we don't speak field bus, that's not our space. So we'll get as deep as our customers want us to go, and then we'll partner. So when you talk about SDN it's been the ability for AT&T to transform its network both internally and externally. And we have to think about cyber to make sure that as we go to a network that has universal CPE on the edge, and if you think about AT&T's legacy network, it was racks and stacks of Cisco, Juniper, and Ciena. That was our network. Hundreds of thousands of boxes around the world providing global WAN connectivity to our customers. And as we pull all that out for them over time and ourselves, and we put in this generic black box that is really just an x86 processor with memory, we now have the ability to drag and drop features onto that. So those features are NFVs, and cyber's a huge piece of that right now, because the legacy of putting a standard Fortinet, nothing against Fortinet, but putting a standard Fortinet firewall on your network makes it so that instead of needing a 100 megabyte circuit, you now need a 200 megabyte circuit. That's not cost effective. So the SDN network allows us to drag in the right type of firewall. So Palo Alto, application-based firewall, much more efficient, doesn't chew up your bandwidth, doesn't need you to double the bandwidth to get the same type of application throughput. So we're looking at future flexibility in cyber as different threat vectors come in. But from our perspective, we have this overarching requirement in the industry. As customers sign up for AT&T, we keep the threats away from that network. So I was talking to to Andy yesterday about this term, industrial Internet of Things. And I said, Andy, no manufacturer would ever put their assets on the internet. It's calling something what it isn't. It should be industrial network of things, because if you architect it correctly, your assets are funneling data up through your secured network. And that network could be an MPLS network, it could be an SD-WAN network, it could be just a pure VPN network, but the opportunity for both leakage and intrusion are vastly reduced versus, you buy a Samsung smart TV, you set it up in your home, and I'm sure that there's tons of threat vectors coming in from Samsung's global network trying to attack your TV and put things you don't want to see. Or, the easiest one is they want to pull down your watching history to see where they can invest money and make a buck, right? So it's a little bit different world. Are we experts in the plant floor? No, we partner with the experts to make sure that from your global IT down to your OT, you have a seamless cyber experience.
Okay, I'm going to ask if there are some questions from the floor. If there are questions from the floor, would you, Mark will give you the mic. Please, if you don't mind, stand and identify yourself
Sure.
and then ask the question. So
I'm-
the importance is that it gets, your
Yeah,
question is heard by our recording.
I've asked a lot of questions today. If somebody else wants to, I'm happy to. Floor up.
You're the pro.
Yeah, so, David Lawrence, Duke Energy. The first one would go to Tom Walker. So these buildings, I keep wanting to think of buildings as an abstraction layer. So I get the HIP switch, and you've segmented, and now you've got some control. So do you ever look at, from an operational point of view, do you ever look at your buildings as an abstraction layer where it kind of manages itself, and you ask it to behave in a certain way, like to produce KW, or absorb KW, or curtail, or throttle? Or you just want to manage it all centrally across all 1,000 buildings? So you have a concept of distributed abstraction in your mind.
Yes, we're actually looking at energy management as a global, across the whole university. At the top of our tree, the main focus of my group is energy management. We're looking at everything that's happening inside that building and bringing that data back in, and then making decisions on how to properly operate that building in the most energy efficient way. And some of that is just dealing with the plants themselves. We don't want to overload the chiller plant in the middle of the summer at 95 degrees out with 80% humidity. We don't want to have every single building just blaring AC at the same time. So there's a lot of different things we do to set the buildings back. We maybe separate the temperature set points by 5 degrees. The end user may get a little bit warmer, but we're not collapsing our whole infrastructure, because we're basically like a little city. We have chill water, we have electricity, we have steam, everything's all distributed out of individual plants. And so we kind of look at everything happening in that building and how they can all tie together. So we're even bringing back data now from the elevators to be able to show how much energy usage is this old elevator using compared to the new elevator in the next building right beside it.
I guess my point is subtle though. Would you allow the elevator to manage itself and give you more or less metadata back to the central to manage? Or are you going to stream it all back? Because we found in some SCADA systems that you can't scale them up. At some point you start to break down. So the idea is to let the building operate itself and optimize itself and let it produce metadata that you would then bring back to central. You can always view what's going on in the building, but maybe you don't do all the governance of everything that's out there. So that's my idea behind abstraction.
Yeah, we don't, there's certain functions that we do, we just let the building do what it's supposed to do. We have specific programming that's in the controllers that lets the building make decisions based on the environment, the temperature, everything. But there's some key pieces that we have to bring back centrally, so that the alarming is a key piece of that. We're bringing back the alarm so that we know, hey, there's something going on in this building, we need to dispatch somebody.
Right. That sounds good. So my last question, I'll go ahead and hog out, is to Subhash, and that has to do with, and it's also to the vendor community here a little bit. So you have a HIP switch, but you haven't really gone to SDN yet. So when I go to SDN, I'm thinking, okay, I'm doing everything with OpenFlow now, and I'm controlling all these routers and flows, and I have it all in place. Let's go back to Subhash for a second, though. I mean, really, seriously. how often are you really going to change the flows inside of a substation that you've built? That's one question. And then if you did go to, let's say you go to 61850, you have a digital substation, you've really only got one box now at the head of it all, right? Everything else is merging units. I don't see a place for SDN in that unless you can, maybe there's a lot more boxes, it's battery and other things, but really how often does it change? Why do you need it? That's one. And then the last question is, how does hip switch tie into SDN?
Well,
So-
that's maybe we take those one at a time.
So let me answer. Excellent question that you asked. And first of all, I want to apologize. And I've been calling you Bill, but David. But here's the most important thing. Think about this, the flexibility. Like I'll give you a perfect example. In Western United States, we got so many RAS schemes that we don't even know. I mean, we can't even count. I mean, there's so many of those. It is a remedial action scheme, which is where a bunch of relays can sit somewhere and make a decision on the flow of the system, right? So now, think about where these systems have to, we have to make a change because there's a change in the nomogram. You know, like we changed it. The nomograms are changed every 6 months, but now we are looking at dynamic line ratings. So we know what the dynamic line rating of the system is now, and now we want to change the flow of the system. At this point, my biggest issue would be the network. So if you have this done, and this is coming, this is not far away. Dynamic line ratings, ERCOT uses that today. You know, and we want that flexibility. You know, we have a throughput of 12,000 megawatts on COI, but our limit is 4,800. It is because of the fact that we are very conservative and based on the thermal limits. But you can imagine that scenario where this SDN would help me get to a point where I can do that dynamically. Of course, going back to this example, we will have scenarios already built in the configuration of those the RAS, but in real time, my operators can change based on my real-time contingency analysis.
Can I ask a follow-up, just a yes or no question? What I'm getting from that, and I'm not an expert, even though I did once work for a utility, it was a much simpler time. So what you're saying is you see you might be able to get additional capacity, rated capacity out of the assets that way if you have this flexibility. Is that what you're saying?
Yeah, technically what happens is today everything is done with a study that says if the sun was shining, if it is so hot and humid and this pipeline, this conductor is 20 years old, and we look at all those things and we look at the insulators and all that and we go, this line is rated at this. And the engineers are very conservative. So if the line capacity is 100 megawatts, they're going to say 50 because they want to be on the safer side. You know? But dynamic line rating, now you know it could be 98 or sometimes it could be 110. It depends upon how the situation is.
Got it.
So,
Okay, can we, go ahead.
Just real quick, because I think what I also heard you say is really how often is network change really going to happen on the utility side. So I think when you look at the business drivers of carrier networks, data center, you know, their message and their drivers are all around network agility. It's the inverse in the industrial. Rather, what we look at is security agility. That's something we definitely lack on the industrial side. So as part of the DOE Autonomous Attack Surface Reduction for Cyber Energy Delivery Systems, please don't ask me to repeat that. Part of that project, we just call it Chessmaster. So the Chessmaster project that we partnered with Schweitzer on, it is all about defining threat state models that we call DEFCONs. So based upon the threat state models, we can define these different policies that we can respond to in a pre-designed, pre-tested way based upon that threat condition. But also to that are the varying operational states. That's where your change comes in. One example that Subhash hit me with the very first time we met is the idea of we've got the HMI at the substation. Well, the substation normally runs unmanned. Should you have a human-to-machine interface if there's no human? sometimes, right? So that represents an operational state, right? So our approach to that is let's define one policy being a bucket for rules of substation 1 normal operations. Have another, that one, basically let's unplug the Ethernet cable from the HMI. And now we have another one of authorized engineer on site for substation 1. When we badge in at that facility, we can automatically trigger that operational state. So by the time the engineer gets to the control room, HMI is functional. When they leave, you remove it. So everything we do is it's a philosophical approach of attack surface reduction. That's where your changes in the switch programming come into play for those different operational states that are really much more towards operational and security change versus network change. Does that answer your question a little bit? Yeah, that's good. Okay.
That's very interesting, I can relate that to, we had a discussion from a supplier and in this meeting, and the supplier was really talking about difficulties exactly with that the processes and people in terms of the security had compromised the, what was a safety system. So I can relate to that as being very important. Did we answer all the parts of your question, David? I'm not sure. I can keep maybe one thing at most in my head at a time. Did we get to all the parts of your question? No. Okay, go ahead.
That's all right. Well, okay, the SDN part of blocking flows and controlling flows, that makes sense. I've only briefly read HIP because I heard about it yesterday, and so I looked at it. So it's the, this host identification protocol. It looks like it's sort of crypto between routers sort of thing, But why do I need HIP for that? And then how does, when you use OpenFlow to talk to an SDN controller, I don't think HIP ties into that, or is it just another protocol?
No,
that's attached?
so and you asked what the differences were. First of all, one of the things that SDN is very good at is that visibility equation. We provide visibility in regards to our HIP switches and the connections we're doing. We do both, though, perform degrees of orchestration. The fundamental difference, though, is an SDN is orchestrating the underlay network and the traditional controls that are associated with networking in general, the VLANs, the ports, and depending on the type of controller, the access control lists of the routers and things of that nature. We're a true overlay network. So HIP is not just encryption, it's also encapsulation of the traffic. We ride on top of the underlay, but what ends up happening is more often than not, and Tom talked a little bit about this, a lot of the traditional controls, IT controls like firewall rules, start to become less important. So, for example, if I've got a perimeter firewall and I've got all my inbound rules, in his case it's 250, we have customers with thousands, complex, easy, error-prone, all that stuff. For certain zones, our customers will say, only HIP. One rule, inbound rule, becomes much simpler. It's about reducing complexity. And so when we're setting up an overlay, and identity-based routing too, is such where it can connect peer-to-peer without any ACL changes. So in Tom's case, one of his use cases, for example, lighting control systems can be very flaky or difficult to manage. And the local lighting controls, the controllers, the servers need to be there. They need to look like they're on the LAN. But for people that want to control things centrally, both from a security and operational efficiency perspective, it breaks. Well, the nice thing about an overlay, when you're connecting peer-to-peer, they look like they're on the same LAN. So it just works. And it doesn't require the changes of the routers within the network, everything in between to support multicast and da-da-da-da-da. It just goes over that encapsulated encrypted tunnel. So, but SDN is important from especially a visibility, and we don't obviate the need for the underlay. You still need routers. You still need firewalls, but they become much simpler to manage.
You have a comment on that?
Yeah, I do. So SDN is, it's interesting. It's a very, very broad term that has many, many different definitions, right?
Yeah,
In the different
I would think it
sectors,
would have some
right?
very different definitions
So,
between
for
you
example,
and AT&T.
you know, one misconception, I think, in the way we implement our underlying SDN technology, we don't use ACLs or anything like that. Everything is based upon the match criteria and then the action, right? So there's no ACLs or anything like that. It's a little bit more advanced of what we're doing with the Chessmaster. One of the things that's really interesting that Schweitzer's really bringing to the table in this next generation of their industrial switches is the concept of on the ingress physical port of a switch of a host to the destination switch egress port of applying encryption, tunneling, or both. Now, that's a very interesting concept because then when we look outside of energy to chemical, oil, and gas, where it's more of a IEC 62443, security zones and conduits, now you have that dynamic programmatic capability of going from a threat state model of 4 zones to maybe 10 smaller autonomous zones. You have that type of capability. But SDN is very interesting, though, because there's a lot of misconceptions. There's nothing virtual about it. What it is a centralized configuration control and monitoring of the underlying fabric.
There's any other questions? It looks like there's, we have time for one or two more. There's one
Awesome.
back here, please.
Hey, Brian Proctor from Security Matters. My question is for Sue Bosch from WAPA. Great presentation. I'm a utility guy, 13 years, ex-utility guy. My question centers around your comment about how you were looking at the behaviors of your operators and looking at their behaviors and probably trying to determine what's abnormal, or there's like an insider operator and he starts opening a bunch of breakers. How does SDN support that? I see SDN as really limiting the attack surface to allowing flows that should be allowed, meaning an operator workstation should talk to your SCADA master or SCADA application. Your SCADA application talks to your RTU, et cetera, over DMP3 or whatever the protocol is that you use. So how does SDN support WAPA in addressing that specific attack vector?
Thank you. Excellent question there, because there are two parts to that, right? One is how does an operator react to that, and then after the fact, how does a SCADA guy go back and look at what really happened? So it is very important for operator to take an action so we continue to have the reliability in the system. So we want to make sure there is some. In the beginning, we saw the operators go, "Those goddamn IT guys, they broke it again." It's always that same comment. But now the first thing they look at and they go, "Is something happening to the system?" The first thing, and then the first thing they do is they call in the SCADA guy and they say, "Hey, come on in, take a look." And then they call their adjacents and they say, "I'm seeing this number. Are you seeing this number on the other side?" Because they want to make sure that everybody's seeing the same thing, because that is how the system operates. The second thing is when the SCADA guy comes in, it makes it easy for the SCADA guy to see on an SGN the flexibility of replaying that and going back from a network perspective what really happened. And also, in some cases actually, where we can move devices into a zone where it doesn't communicate and damage the network or other devices any more than it should. For example, let's say, since you're a utility guy, let's say our ICCP servers. ICCP servers are the ones that communicate between the utilities. So utilities have so much that we go and communicate with our devices, and the ones that we don't have, then we go get that data from our adjacent utilities, because we are all interconnected. So most of the times we see a lot of bad data coming in. And if let's say we define how the behavior is for ICCP, and if you cannot be perfect, and let's say if that happens where one of my ICCP servers is isolated, Now it is the flexibility of the SCADA guy or the operator itself to move that back into a zone where it starts operating again. So there are those flexibilities that we have right off the bat, and it's all about the time, right? It's not about bringing the network guy, the SCADA guy, the server guy, everybody in. You know, it is about the time it takes to resolve the problem and the amount of data that SDN presents to us at the time to show what is really going on.
Okay. Thank you all very much. Maybe we should give it up for these panelists and speakers.